Hello students, today in this section after reading throughout the fluid mechanics, we will be trying to apply those concepts to the questions that have been asked in IIT-JEE Advanced, and we will see how to apply those concepts for solving those kinds of questions that are being asked in such high level examinations. Let's solve some of the previous year IIT-JEE questions. Now the first question reads like this: a cubical block of wood of a specific gravity 0.5 and a chunk of concrete of a specific gravity 2.5 are fastened together. So if this is wood and then you have a chunk of concrete of a specific gravities are given, they are fastened together. Now the ratio of the mass of the wood, it's given that the mass of the wood to the mass of the concrete, if I denote this mass of the wood by mw and mass of the concrete by m of concrete c. This is given as 0.x. Now this is the equation that has been given to you. Now which makes the combination to float in its entire volume submerged under water. Means it's like this: when you put it in water with its entire volume submerged like this, it is floating. It's floating like this with its entire volume submerged. That's given to you. You have to find the value of this x. Now if this entire volume is submerged and is floating, what does it mean is that, applying the Newton's law, what we know is that the buoyancy force that's acting upward is balanced by the weight of this, because it's floating. So the net forces are 0. So what is the net force that will be acting upward? Buoyant force will be the total volume of this, volume of the concrete plus volume of the block into, this is the total volume, and this volume will be same as the displaced volume of the liquid. So into the density of the liquid, which is it's given as water, into G. This is the buoyancy force. Now this buoyancy force must be equal to the weight of this. Now weight of these two is the mass of the concrete plus mass of the block into G. This is what is given to you. Now what we do is that block or wood, whatever is given, mass of the block, mass of the concrete. Now this is the equation that you have. What you see, write it here is this. From this you will get that the mass of the block is 0.x times mass of the concrete. Okay. Now the second equation from the flotation condition we have got is volume of concrete plus volume of block into the density of water into G. This is equal to, this is the buoyancy force, the weight of displaced volume of water. This is the weight of mass of C plus mass of B times G. Now this G gets cancelled out. Now how we can write the volume of C? Now we know that density is mass by volume. So volume is, so if you write volume in terms of mass and density, what we have is mass of C by density of C plus mass of B by density of B. This is in terms of mass and density into the density of water is equal to mass of C plus mass of B. Okay. Now what is the density of concrete? Now since its specific gravity is 2.5, that means its the mass of concrete will be 2.5 times the density of water, because we know what is specific gravity, it's the relative density with respect to water. So if you put the value, what you will have is mass of concrete by, this will be 2.5 times rho w. So this rho w will get cancelled out this with rho w, and then mass of B by rho B. Density of B is 0.5 times rho w. Right, this is mass of C plus mass of B. Now this rho w, this was rho w, this will get cancelled out with this rho w that you had. Okay. So now putting this in the equation, what we have is mass of C by 2.5 means it's 5 by 2, so it's 2 by 5 plus mass of B. Mass of B, we can put it in terms of the mass of concrete, 0.x times mass of concrete. This is equal to mass of concrete plus mass of B is again 0.x times mass of concrete. Okay, so if you solve this equation, what you have here, you know, we can cancel this mass of concrete with this mass of concrete. It's get cancelled out with mass of concrete. So what we have is 2.2 by 5. We can write this as 0.4 plus 0.x is 1 plus 0.x, right? This is 1 plus 0.x. So this is 1.x. This is actually 1.x. So what I have here is 1.x times minus 0.x is 0.4. This is the equation that I have got. Now how to find out the value of x? That's what you have to find. You have to find the value of x. Now what value of x will satisfy this condition? What value of x will satisfy this condition? Now it's very easy to look at the values. Now if you put x equal to 2, you can see that it will be 1.2 minus 0.2, that is 1.2 minus 0.2 will be 1. So likewise, if you put the value, now if you put the value of x is 4, you will have 1.4 minus 0.4, that is 1. This was 1 plus 0.x. This was 1.x, it was 0.5, it was 0.4, right? This I got 1 plus 0.x. So this was 1.x minus 0.x. Okay, mass of B was 0.x times mass of C. Put the value, we have missed the value somewhere. Mass of C by 2.5, it's 5 by 2, so it's 0.4 times mass of C plus, okay, see, this is not 0.x, this was 0.5, right? 0.5 means this is twice of 0.x, okay? So if you put this value here, it's actually minus twice of 0.x, this is 0.4. So if you put the value we had taken, so if you put 0.2, x equal to 2, what you will have is 1.2 minus 0.4. This is actually equal to 0.8, but this is not equal to 0.4. So x is not that value. So by hit and trial, if you put the value of x equal to, suppose now I try 6. So you will have 1.6 minus 2 into 0.6. This is 0.4. This satisfies this equation. That means the value of x is 6. So by this method you will get that x equal to 6. Once you have got this equation, you can put the value. Now you can also think why I haven't multiplied this 2 into 0.x, because we are not sure what is the value that you are going to get here, whether it will be 0.2 into x or it will be 1 point something, because if the value of x is greater than 5, like 6, so if you multiply 0.6 with 2, you will get 1.2. So you are not sure of the values that you will get here, so you cannot multiply it. Let's move to the next question. An iceberg is floating partially immersed in seawater. Okay, so let's suppose this is an iceberg, it's partially immersed up to this. If the density of seawater is given, the density of seawater is 1.03 gram per centimeter cube, and of the ice it's given 0.92 gram per centimeter cube. What is the fraction of the total volume of iceberg above the level of seawater? Suppose above the level of seawater the volume is V dash, I assume it is V dash, and the total volume I assume is V. So the question asks me to find out fraction of the above the level, that is V dash by V. This is what the question asks me. Okay. Now it is given to you that it's floating, right? That means the weight of this must be balanced by the buoyancy force. What will be the weight of this? Weight of this will be volume into its density of ice into G. This must be balanced by the buoyancy force. Buoyancy force will be the weight of displaced volume. Now the displaced volume of liquid will be V minus V dash. This is the volume that is displaced, because V dash is outside. So that means V minus V dash is inside. This is equal to the volume of displaced liquid. So this displaced liquid into the density of seawater into G. So if I solve this, what I have is V minus V dash by V is rho I by rho SW, density of ice by density of seawater. Okay. What is density of ice? Ice is 0.92, so this is 92 by 103. So if I solve this, what I have is 1 minus V dash by V is 92 by 103 That means V dash by V is 1 minus 92 by 103. What you get is 103 minus 92, that is 11 by 103. Okay, now the answer is given in percentage, so we can convert this in percentage. V dash by V into 100. What we'll have is 1100 by 103. Now you can see from here that 103, 10 times of this will be 1030. It's greater than 10. Okay, it's greater than 10, but not like 34, right? It's slightly greater than 10. So we can straight away say from here the correct answer is 11%. You don't need to calculate it because it's not definitely not going to be 34, and definitely it's not 8 because it's greater than 10. So the correct answer is 11%. Let's move to the next question. The weight of an empty balloon on a spring balance is W1. Okay, let's make a spring balance. We have an empty balloon. Its weight that is given is W1. The weight becomes W2 when the balloon is filled with air. Now this balloon is filled with air like this. And then we have a weight, it's W2. Let the weight of the air itself be W. Now it's given here that the weight of the air that is there, it is W. Neglect the thickness of the balloon. You have to neglect the thickness of the balloon. What does it mean? It means that the volume occupied by this is 0. The statement this is the volume of balloon is 0. Because you have to neglect the thickness, so its volume is 0. When it is filled with air, also neglect the difference in the densities of air inside. What you say is the density that is outside and inside, both are same. The density of air is same. What is the relation between W2 and W1? What is initially W1? This is simply the weight of the balloon. Whatever is the weight of the balloon is W1. Now when you fill it with air, what is the weight of the air? Weight of the air is W. Okay. Now what will be this W2? W2 will be the weight of this balloon, that is W1, because W1 was the weight without any air. W1 plus W that is given to you. What is? It's the air. Now the air is filled within this. Minus the buoyant force that will come in picture, because once it has finite volume, now it has displaced the air. Since it has displaced the air, it will have a buoyancy due to the air. So this will be W2, right? Now we have to find out what is the buoyant force of the air. Now the buoyant force of the air will be the volume of the air into density of the air into G, right? This will be the buoyancy force, the volume, weight of displaced volume. So this is this. Now we know that this is actually equal to W, which was given to you, because the density of air inside and outside is same, and the volume that has now been occupied by this balloon is actually the same as the displaced volume. So what you get is this W is actually equal to buoyant force. So this will cancel out. W2 is actually equal to W1. So the correct answer, if you look into, is A. Let's move to the next question. Water coming out of a horizontal tube at a speed V strikes normally a vertical wall close to the mouth of the tube and falls down vertically after impact. Okay. If this is wall, liquid is coming from this, it strikes this and then falls down vertically. The water is falling down vertically. Means after collision, it doesn't have any velocity. It loses all the velocity and simply falls down. It was moving with V, collides, falls down. So initially it has a velocity V, finally the velocity becomes 0. When the speed of water is increased to 2V, what will happen to the thrust exerted by the water on the wall? Now thrust we know is pressure by area. Now if this is moving with velocity V, what will be the force exerted on the wall? Force exerted on wall, we know force is actually the change in momentum. Force is actually the rate of change of momentum, right? What is the change in momentum that is happening? Suppose we find out what is the change in momentum that is happening in time dt. So this is, suppose you consider a time dt. Now in time dt, what length of the water will flow out? It will be v dt if the velocity is v, right? In time dt, v dt length will flow away. Now if v dt length is flowing away, what is the volume that is flowing away? Volume will be this into its area. Okay, this is the volume that is flowing away. What is the mass that is flowing away? It will be into rho. So this is the total mass that is flowing away in time dt. Okay. So what is the momentum that flows away? It will be into v. So that is rho a v square dt momentum is the momentum that strikes this. So what is the change in momentum? Now since initially it had this momentum, final momentum is 0 because the water is coming to rest. So this is the change in momentum. So what is force? Force will be dp by dt. Force is dp by dt, this is the magnitude. This is actually rho av square. What will be thrust? Thrust will be this by area. That means thrust is actually rho v square. Now let's go to the options that we have. Now the thrust exerted by the water on the wall will be doubled if you make v as 2v. So if you double the velocity, now it's very evident here. If you double it, the thrust is becoming 4 times because it's depending on v square. So B is the correct answer. Other option that we have is energy lost per second by water. Now what is called the energy lost per unit time? What is energy per unit time? That's power. So you have to actually find the power lost. What is power? We know power is force into velocity. Okay. Now what was the force that we got? It was rho a v square. What will be velocity? It's v. So it's rho a v q. So the actual value is rho a v q. So what will happen when v the velocity change from v to 2v? The power will become 8 times because now it depends on v q. So if you look at the options, this one is the correct option. Let's move to the next question. Water is filled in a container up to a height of 3 meter. A small hole of area A is punched in the wall of the container at a height 52.5 centimeter from the bottom. Container is there. Here the water is filled up to a height of 3 meter. Okay. Now a small hole of area A is punched in the wall at a height 52.5 centimeter from the bottom. It's given from the bottom. That is 0.525 meter. Here there is a hole that has been punched in. Now the cross sectional area of the container. Now this is given as capital A and this is given as small a. Okay. And then the ratio is given. You have to find out v square. How to find out this? Now what we will do is that we will apply the Bernoulli's equation first. Now if you apply the Bernoulli's equation at this point and at this point, what will be the Bernoulli's equation for this? Here the pressure will be atmospheric pressure. What will the potential energy term? If I take this level as my reference level, this is my reference level, then this will be rho g. What is this height? This height will be 3 minus 0.525 plus half rho v square plus half rho whatever is the velocity at a square. This is the Bernoulli's equation term for this point. Now then I write this for this point. At this point the pressure again is PATM. Why? Because this is again exposed to the atmosphere. This is outside. If you consider this point, it is exposed to the atmosphere, so it's PATM plus this term is 0 here because this is actually at the reference level. So this is 0 plus half rho v b square. Whatever is the velocity at this point, if you consider this point as b, this is this. So if you solve this, what you see, this will get cancelled. This one is, again rho is also getting cancelled from all of this. So what you have is g into 3 minus 0.525, it will be 2.475. Okay, 0.525. Okay, this is 2.475 plus VA square by 2 is equal to VB square by 2. Okay, this is one equation. Now we have two unknowns and we still have only one equation. Now how to find it? Now we know that the water that is coming down from the top in any unit time, if in any unit time water level is coming down by this, then the same amount of water must have flown out from this hole, because the volume that is coming down is equal to the volume that's coming out, because of this water flow is that this level is coming. So in any unit time, the volume that is coming down from here must be equal to the volume that's coming out from here. So if you apply the equation of continuity in any time dt, we'll have capital A into the velocity of A into dt must be equal to small a into velocity of B into dt. dt get cancelled. What we have is VA by VB is equal to small a by capital A, that is 0.1. So if you put this value, what we have is VA is 0.1 times VB. Okay, we input this here. What we get is, this is 24.75 into 2 is VB square minus VA square, right? We bring this 2 on this side. What we have here is VB square, this is 0 into 2.475 plus VA square by 2 is equal to VB square. So this is VB square minus VA square. What we get is minus 0.1 VB square when I put the value for VA. So what I get here is, solving this equation, we'll have 24.75 into 2 is equal to VB square minus 0.1 VB square. What will be this value? This value will be VB square into 0.99. This will be 1 minus 0.01. So this is 0.99. So what we'll have is, this is VB square is 0 by 0.99. Okay. Now what you have to find out, the cross sectional area where V is the velocity of water coming out of the hole, that is VB. So we have to find out VB, and this is the value that I have got. If you solve this, what are the values I am getting? This, if you get cancelled out, this is 2475 into 2 by 99. So it's 4950 by 99 is VB square. That is 4950 by 99. If you see the value, it's greater than 48. The value is 4950 by 99. This is your VB square, and this is what you have to find out. So you can see it from here to which value is closer. So 99 by 4950, we can see it's greater than 48, but it's less than 51. It's greater than 48, but it is less than 51. You can see it from here. It's very evident from here. 99 times 5, it's 495. So it's actually getting cancelled out. It's 50. 5 times 99, 5 times is 495. So it's 50. So if you look at the, okay, we have the correct answer here. So the correct answer is 50. So that's it in the fluid mechanics session fluid mechanics part, guys. See you in the next session. Hope you guys will do well with the question. You don't have any problem, further problems dealing with the question. If you have any, you can post your doubts in the batch forum or on the private public batch forum. So thank you, guys. Having gone through our video lectures and video solutions may have cleared most of your doubts. For any further doubts, you may visit our site www.askIITians.com. On the site, you will find a tab called Ask a Question. Click on that tab. Clicking on the tab will take you to the next page where you will find an icon Ask Experts. If you want to ask any questions, you can select the category of the questions. Like if you want to ask question from suppose wave motion, click on that option wave motion, paste your doubts here. If you want to attach some image of the question, you can attach the image also. Your question will be answered within 24 hours to 48 hours. So students, we have finally covered the topic of the fluid mechanics, where we started with the fluids at rest. We saw some of the properties like buoyancy and Archimedes principle. Then we moved over to the fluid mechanics and the dynamics part, where we dealt with Bernoulli's equation, the equations of the continuity. Then we went over to discuss some of the non-ideal fluid characteristics like viscosity, surface tension and various other things. And then we saw some of the questions that have been asked in IIT-JEE Advanced and how we can apply our knowledge to those questions. I hope you enjoyed the session. For any further videos on physics, chemistry, biology and mathematics, stay tuned to askIITians.com. Thank you.